Hi everyone, this is Amy from the Helms Academy, and today we'll be doing our Math Roundtable recap from February 25th, 2021. First, we're going to start, as always, with our steps to solving a word problem. If you're solving a word problem, you start by finding the important information. If you're able to highlight or underline it, even better. Then you'll need to figure out which operations are needed to solve. Where will you need to multiply, divide, add, subtract, create a proportion? And then, if you can write out the problem using the numbers and operations, you'll be able to solve. So for word problem 1, it says a national park keeps track of how many people per car enter the park. Today, 57 cars had 4 people, 61 cars had 2 people, 9 cars had 1 person, and 5 cars had 5 people. What is the average number of people per car? Round to the nearest person. Okay, so if I look back over here, I see some important numbers. I see that I'm trying to find an average. So let's take that information and see what we can come up with. When I read people per car, I think about it as a division sign. So people per car, and the per is the dividing line between them. If I can remember that about the word per, that's going to help me solve this problem ultimately, because that will help me get the average. Now, if I look at how many people we have, I would have to do some multiplication because for every one of those 57 cars, there are 4 people inside. So I'll do 57 times 4, which is 228, 61 cars with 2 people, so 61 times 2, which is 122, 9 cars with 1 person, so just 9 people there, and 5 cars with 5 people, which is 25 people. Now, if I want to get the total number of people from all of those different types of cars, then I can add all the people together for 384. And if I wanted to know how many total cars there were, I would take all of those first numbers, 57, 61, 9, and 5, and I'd add them together for 132. So now I know my number of people and my number of cars, and I can now get an average from that. So again, if I plug in where the people per cars is, if I plug in the people over the top line and the cars under the bottom of the line, then I will get 384 divided by 132. And the average then is 2.9 people per car. Now we know that you can't have 0.9 of a person, so we need to round that. And because it's 0.9, anything 5 or above in that decimal place goes up, which means it'll make it just an even 3. For word problem 2, it says Nancy, Jennifer, Alex, and Joy ran a race. Nancy's time was 50.24 seconds, Jennifer's was 50.32 seconds, Alex's was 50.9 seconds, and Joy's was 50.2 seconds. Whose time was the fastest? So you can see here one of the things that may draw your attention immediately are the numbers, and that's going to be an important information for us to look at. In this case, it's asking us who is the fastest. So the first thing I want to do is compare what my decimals say. I see 5 or 50.24 and 50.32. Now you'll notice that when I rewrote it, I rewrote Alex's as 50.90. Why? It's much easier to compare decimals if they all have the same number of decimal places. And with decimals, you can add a 0 to the end and it won't change the value. So in this case, it's much easier for me to compare when I see 90, 24, 32, versus trying to remember that 0.9 is larger than 0.32, etc. Same thing with the 50.2, I added a 0 there to make it 0.20. So if I line all of these up, I can figure out which one's the smallest and which one's the greatest. But it's asking me which one is the fastest. Now think about running a race. Do you want to run it in 23 minutes or do you want to run it in 30 minutes? Well, if you want to win, you want to get the faster time, which is actually going to be the smaller number. So in this case, we're looking at 50.2, which was Joy's. For word problem 3, it says Martha has $20 to spend and would like to buy as many calculators as possible with the money. The calculators that she wants to buy are $4.50 each. How much money will she have left over after she purchases the greatest possible number of calculators? So To figure this up, we need to look at our numbers. We know she has $20 and she wants to buy calculators that are $4.50. How many can she buy? Well, we need to find out how many times 4.5 goes into 20. So I can divide them out. 20 divided by 4.5, we get 4.4 repeating. But I know in whole numbers, it's going to mean that I can only buy 4 calculators. So it says I'm going to have some money left over. And how would I figure that out? Well, I need to figure out how much money I spent on those 4 calculators to be able to know what's left over out of that $20. So to find out how much money I spent on the calculators, I would put in 4 times 4.5 or $4.50, which is $18. Now, if I subtract that $18 from my original 20, how much change is left? $2. For word problem 4, it says a factory that is working at 90% capacity is shipping 450 cars per week. If the factory works at 100% capacity, how many cars can it ship per week? Now, anytime I see a comparison like this that involves 2 figures and then 2 other figures where one is missing, that signals in my head that we need a proportion. So I'm looking at my percentages, 90 and 100, and I'm looking at the number 450, and then realize when we're missing how many cars, it would be at 100% capacity. So that would be my variable, or you could put it down as a question mark. So if I'm going to organize this as a proportion, I need to keep the 2 connected figures in the same fraction. So 90% and 450. Doesn't matter necessarily if I put them in on the top or the bottom, which order I put them in. In this case, I put the percentage on the top and the number of cars on the bottom. Now, if I want to know what it is at 100% capacity, I'm going to trust that I will know through a proportion. And what that means is that I will set up my proportion almost in the same way. So it's because I see the percentage is on the top in the first one, I'm going to make sure the percentage is on top in the second one, which is why you see the 100 there above the line. And below the line, I need to make sure it matches with the number of cars. So 450 on the left side, and on the right side, just a question mark because we don't know. You could also use a variable like X or C for cars. Now, how do I solve this? Well, I cross multiply and divide. So multiply the 2 numbers that are diagonal from each other and then divide by the other number. In this case, it's 450 times 100. And I divide all of that by 90, and that gets me 500. Another trick with this problem is to look at the answers that are given. Right away, I know 90% is less than 100%. So I can imagine that what they're making at 90% is going to be less than what it'll be at 100%. That means that the answer has to be greater than 450. So before I even start, I would look at D and be able to cross that off. Now, word problem 5 says, ribbon is wrapped around a rectangular box that is 10 inches by 8 inches by 4 inches. Using the illustration provided, determine how much ribbon is needed to wrap the box. Assume the amount of ribbon does not include a knot or bow. Now, how do I figure all of this out? Well, I need to think about where the ribbon touches. So, for example, I see the ribbon across here. This ribbon is going to be the same distance across as this down here, the 10 inches. So I know there will be a 10. And I also know that the same ribbon is going to be on this side this high, which has to be the height of the box, which I know from over here is 4 inches. Now, whatever's on this side is also on that side, and whatever's on the top is also on the bottom. So if I know one of these lengths here and one of these lengths here, I can just multiply them by 2 to get the full length of this center ribbon. So you can see I did 4 times 2 plus 10 times 2. Now I need to do the same thing with this other ribbon, moving what looks like vertically on the screen. So first we start with across the top and across the bottom. What is this distance? Well, if I go down here, I can see that it is 8 inches from all the way across. So because this is a rectangle, this is the same, this is the same, this is the same. That means this line is going to be the same. So I can do 8 times 2 because we have both the top and what's underneath that we can't see. And then also another 4, because we know this is 4 inches high. So we're able to use that same 4 measurement and multiply it by 2. Alternately, you could go to this 4 down here and multiply it by 4 and take this one off. So if I put all of those pieces together, I get 8 plus 20 plus 16 plus 8, which is 52 inches. Thank you so much for solving with me today, and don't forget to check out all the other videos that we have here on our Helms Academy YouTube channel. If you like a video, feel free to share it, give it a thumbs up, leave a comment, and don't forget to subscribe. You can also check out the Helms Academy's daily quizzes on Instagram and Facebook, and you can learn more about us on our website at helmsacademy.org.